Hi, my name is Lee Lorenzo, and this is my Physics 2211 Lab 3. So the purpose of today's lab is to use fundamental physics principles and a simulation with code in order to, 1, find the mass of a simulated black hole being orbited by a star through analyzing the motion, and 2, we will also be finding the initial velocity of a spaceship leaving the planet using this previous data in order for the spaceship to fly around the black hole without crashing both into the planet or into the black hole. So some of the fundamental physics principles that we'll be looking at today include Newton's second law, which we have been looking at in previous labs as well, which is F net equals dP over dt, or can also be written as the average of F net is the change in P over the change in T. Deriving this formula, we'll also be looking at the position update formula as well as the velocity update formula, which can be seen below, and they are found derived using the original momentum principle. The next formula we'll be looking at is the formula for the gravitational force, which is given by the image below. And within this formula, big G is a constant, M1, M2 represent the masses, and R2 represents the distance. And the direction will be given by R hat, which we'll be looking at later. And for part 1, one note is that our system we'll be looking at is a black hole, and the surroundings will be the star, which has a given mass. So for the glow script code, we had to update given these initial conditions. The mass of the star was given, which was 2e raised to the 30th, and delta t was given, which was assuming 1 day, and that was found by converting that into seconds, as you can see boxed in red. And we'll also be observing at t equals 0. Next, for the glow script code, we also updated the formulas. One important thing to note in these formulas is that F net is equal to the perpendicular component plus the parallel component, which you can also see boxed in red. So after updating the formulas in GlowScript, I was then able to get the output from the code of the mass as well as the F net and its components. Now, in order to find the actual mass that we will be using in part 2, I took all of the masses outputted by the code and put them into Google Sheets in order to find the average of these to get the final mass. And this was found to be 1.15 raised to the 34th power. For part 2, we will be using this mass of 1.15 raised to the 34th as our black hole of the mass, and we also be taking into account that the new system will be the spaceship and the surroundings will now be the black hole and the planet. So we updated some of the formulas. We have to update the initial conditions using the 2 formulas mentioned in the fundamental physics principles. And for the second part, you can also see here that we have to find the updated net force. So in order to find this, we had to update all of the forces using the formula for universal gravitation. And in the end, we were able to find the F net both on the planet and the F net on the ship. And in the bottom, you can see we also had to update using the velocity and position update formulas. This is the results for part 2, so that the spaceship, which can be seen in magenta, is as close to the black hole as possible without crashing into the black hole or crashing into the planet. The initial velocity that I found was to be -1 e to the 7th in the x direction and 9 e to the 6th in the y direction. And these values are found through guessing and checking to see which values make it so that the spaceship did not crash. Some possible sources of error is that in part 1, the mass was found through using the values in the given time and averaging them, but this may not be entirely accurate as we could have used a longer time frame to get more masses to find a more accurate mass. For part 2, the initial velocity was found through guessing and checking, and again, this is not entirely accurate. The distance could have potential to be smaller than what I found it to be. It could have been closer to a black hole, but since it was through guess and check, it was more of an estimate. For the first question, what if? Though F net and dP dt will have the same mathematical result, they are not exactly the same in terms of how we find them. So when calculating F net and its components, you need to know all of the acting forces, which requires a lot of information. But when finding dP dt, the change in momentum, you only really need to know the change in velocity and the mass, so it is much easier to find in comparison. For the what if question, instead of wanting to take a quick look, you decide you want to enter into an orbit around the black hole. What initial velocity would your spaceship need in order to enter some type of orbit? In order to find this, I also played around with guessing and checking, and I made my initial speed in the x direction smaller. And in doing so, I was able to find the initial speeds for the spaceship so that it would be in some type of orbit around. And as you can see, this is the result, where you can see that magenta and cyan are both orbiting around the black hole. I'd like to thank you for watching, and I hope you enjoyed.